Hi everyone. We will talk about initialization of mruby. Before this session begins, we briefly summarize our session. After our self-introduction, we will talk about mruby and its initialization. We have a problem of initialization of mruby, so we will talk about how to improve it. Our solution is mrbgem, a mrbgem for modified mruby. Finally, we will show our result and future works. Let me introduce ourselves. I am Yurie. I am interested in microcomputer and real-time OS. I'm a member of the Topaz project. Topaz project makes kernel for real-time OS and tools. I do demonstrations and presentations at many exhibitions. In addition, Mats and I are planning to virtually join to talk about mruby at the event called ET 2019, which is held in Japan this evening.
And I'm Masayoshi Takahashi. I've used Ruby for 20 years, but almost used CRuby, not mruby. In addition, I'm one of the organizers of RubyConf in Japan. And the next RubyConf will be held in Matsumoto City in next April. Please come and enjoy. And we published a zine called Introduction to mruby a few months ago. This zine. I bought a sample of the book, so please let me know if you are interested. The topic of our session is initialization of mruby. In this session, we talk about mruby, its initialization, and our improvement of it. So, first of all, we talk about mruby. mruby is an implementation of Ruby like CRuby, JRuby, Rubinius, Opal, and Artichoke. It's also called a lightweight Ruby. mruby is a very small implementation compared to CRuby and JRuby. It complies with the ISO standard of Ruby. mruby has mainly two target areas: embedded systems and embedded in applications such as servers and games. We have focused the former, embedded systems. We recently used a board called M5-Stack-C to run mruby. This is M5-Stack-C. M5-Stack-C is a new board made by M5-Stack company. Its size is very small, like this, but it's very powerful. The board uses ESP32 microcontroller, and it has Wi-Fi, Bluetooth, small LCD, sensors, battery, and so on. The M5-Stack-C diagram looks like this, right side. And you can add extra sensors and or actuators with the board. We already installed mruby and a sample Ruby program on it. Let's show the demo. This is the clock. Can you see? ちょっと難しい。It's a little difficult. You can make adjust of time using NTP with its Wi-Fi. And when you shake it, it shows two dices. And more shaking, more dices. F560 has motion sensors, and when shaking it, the sensor detects its motion or the acceleration and show dices. The original program of it is in Arduino C++, so we ported it to mruby.
Now back to our topic, initialization mruby. While thinking about the initialization of mruby, I made a quiz of mruby. How many objects are created in initialization of mruby? The important hint is all classes are objects. So the number of objects is always greater than the number of classes. The answer is number 3, 212. But actually, it depends on the configuration of your mruby. The library of mruby is implemented as mrbgems, like standard gems in CRuby. So mruby is smaller than CRuby. Anyway, many objects are generated when initialize mruby. We use the word initialization, but we have not defined the meaning of this word. In this session, initialization means everything before executing your Ruby project. Sorry, your Ruby scripts. There are 3 main parts of initialization. First, initialization mrbgem. Second, initialization GC system. Third, initialization of classes and modules. Object, string, integer, array, and other standard classes should be defined before running your code. So it should be defined during initialization process. In addition, method of the classes should be defined too. There are important things in initialization. We make brief expression of mrbgem. The implementation of mrbgem is a struct called mruby state. It has its context that execution environment. Context has a code info array and a stack. Both are created in initialization process. The main thing of initialization of GC system is the allocation of memory. Objects of mruby are implemented as R value. R value is union, fixed size structure. R values are all the same size. During initialization of GC system, mruby reverses a lot of memory for R value. At last, we explain initialization of classes and modules. Classes and modules are implemented as struct R class. R class is a kind of R value. R class has a reference to method table and instance variable table. Method table is a map of method name and method body. Likewise, instance variable table is a map of variable name and value. Moreover, instance variable tables is also used for providing information about the class as described below. Method names are also represented internally as symbols. So you must also initialize the symbols. Now, let me explain what we want to improve. The challenge here is memory consumption. All class and method initializations are spread out in memory. But most classes and methods don't change at runtime. So we want to save more environment with low memory, such as microcontrollers. So we came up with a way to improve memory consumption. Microcontroller has its own RAM and flash ROM. Flash ROM has more capacity than RAM on many microcontrollers, so using ROM instead of RAM can save memory consumption. However, flash ROM cannot be written while initialization is in progress. Flash ROM is of course ROM, meaning it's read-only. You can actually write blocks, but you can't write like RAM. Alternatively, you can change the source in the form of C source code. So we tried using pre-execution and code generation to solve this problem. Pre-execution is a process like the figure. That is, pre-processing is done before execution, as a value that would not normally, that from execution, would have been given from the beginning. Initialization is, as the name suggests, the first thing you do. So if you want to do something before initialization, you need to do it separately from normal execution. To take advantage of the pre-execution result, we will perform a two-step execution. First, run mruby for code generation only. This is to generate pre-execution results in the form of C source file. That generated C files are then combined with the mruby core to create another executable. This executable reduces memory consumption of mruby. So let's talk about mrbgem.
NVGen stands for non-volatile mruby generator, and it's actually implemented as mrbgem, mruby beam nbgem, but mruby needs to be modified to run it. As mentioned several times, nvgem generates two C source code. One is a source of symbol information. The other is a collection of objects and their associated data structures. When creating a new application with nvgem, you will combine these generated sources with mruby itself and other codes to create a new executable. Now, let's take a closer look at memory usage. If you use the C language, you may have heard about memory classification and memory maps. Memory is divided into some areas, such as read-only data, and heap and stacks. Constants are placed in read-only data, which is usually in flash ROM. Global and static variables are placed in data, and memory allocated during execution is placed in heap. In this talk, we are going to use the data in heaps as well to reduce consumption by using raw data and data. This table shows how each category is used. Everything in the table is in heap for normal mruby. This is how nvgem changes memory usage. Let me explain in more detail. Normally, all internal data and methods associated with a class are created in the heap. In other words, it's all in RAM. nvgem, on the other hand, uses data and ROM space inside of a heap. Suppose a new method is added. In that case, the method information is placed in RAM, not ROM. Also, when classes are created or objects are created, they are placed in RAM. As you can see, mrbgem is intended to improve execution at the time of initialization and does not change anything after the initialization process. Here is a list of what mrbgem does. Collect the generated object as well as information related to them. Then it dumps the object itself and its method in C form along with its associated information and symbols. Finally, dumps the mrbgem itself after pre-execution. This figure provides additional information on memory usage. There are 3 patterns for representing mruby objects in C data structure. For integer and symbol, you can simply express the value as mrb value. But for other classes, you need R value or more data. Object, class object, and class object are second. String object and array object are third. mrb value is simple. Its immediate value and type tag bits. Symbol and fixed noun objects are represented only by mrb value, but others need R value. R value is the basic data structure for representing objects. R value consists of a common object header and class-specific items. For example, R class consists of a common object headers, a pointer to an instance variable, a pointer to a method table, and a pointer to a superclass. For example, the foo class on the left is converted to a data in the form of light. We also explained method. The data structure of a method is different when the method definition is written in C than in Ruby. Both use struct rproc, which is a kind of R value. Methods defined in C has a reference to the C function, while method defined in Ruby use a structure called irep, converted from Ruby code. Irep is created by dividing Ruby code into methods and blocks. For example, such a method definition and method execution would create 2 ireps. Irep has more information than bytecode. It contains the number of local variables, registers, and symbols used in blocks and methods. Irep can also be nested, so a pointer is provided to do so. You can use the mrbc command to see the result of the irep conversion. This is the result of converting the Ruby code to irep using mrbc command. I will also describe the challenge that had to be solved when creating mrbgem and how to solve them. The Ruby object rValue contains bit of flags in its data structure. For example, whether an object has been frozen is done using this flag. Therefore, you should reproduce this behavior when placing rValue in RAM. So, unlike normal rValue, when we have a C array in the data areas with flags stripped out, and rValue has an index into that areas. This allows a large number of rValues to reside in ROM. It also extends mruby's DC. The DC mruby use is called a tricolor DC because it performs DC by assigning 3 colors: black, gray, and white to add value. Objects placed in ROM are marked red to ensure that DC works correctly when using ROM. Method definitions also need some ingenuity to make full use of RAM and ROM. Once all methods are in ROM, you cannot add new methods. For this reason, we have provided pointers to additional methods tables in the instance variable storage areas. You can now search for methods that are added later. We show another demo. Okay? No. In trouble? Okay.
Sorry. Send data from this device to the server. This time, we will use AWS IoT. Data is sent to the server via Wi-Fi. The network uses our Wi-Fi router that is used for tonight's session. This was provided by the lightweight mruby forum. Thank you. The communication protocol uses MQTT. The M5 stick C has a 6-axis motion sensor. Motion sensors, also called accelerometers, detect the movement of a device. The published code looks like this. The device gets a sensor value and publish it to the server in JSON format. Displays the data sent by the device to the server as a graph. This uses Elasticsearch and Kibana. I get the sensor value with M5 stick C and publish to AWS IoT. This is AWS screen. This sensor, 継続。ちょっとカーソル。Sorry、カーソルが、いた。Where is my cursor? いた。This is topic name, topic 1. And click this. This is this sensor's value. And this is Elasticsearch pages. This URL click and display Kibana. This is shake and click refresh sensor value でここに値をどの辺この辺にエンターsorry ここか This is the display of enter number あれ OK かなsorry ここに often enter for example 3見えないenter 3 OK sorry 見えないあれオフになってるあれ時計かな Sorry try again Where is my cursor? Cursor. 左。あ、サンキュー。ここに、あれ？ここになんか3が選べてます。3になってますか？で、この辺でSorry, I speak Japanese. Sorry. で、あ、そこだな。そのまま押せばいい。Please wait. これで変わった？変わりましたか？あ、オートリフレッシュ。シェイクシェイク。あ。Like this. Thank you. カス。あれ？スライド？Sorry, my slide is. おや。これいいの？ああ。Sorry. I actually tried to see how much memories were reduced. mruby used RAM over 100 kilobytes with default mrbgems. Our first trial in last year, we can shrink its half size of mruby under 100 kilobytes. Moreover, with mrbgem, mruby itself was able to use less than 20 kilobytes of RAM. We have some future works. Thank you. First, we should support mruby 2.1.0. In addition, we will also provide feedback to mruby itself. We wanted to integrate it by RubyConf, but due to disagreement with Matt, we are not going to be able to merge it as it is. Therefore, we will consider how we can do it. Finally, let me make a few acknowledgements. The Ruby Association supported our development of mrbgem. The mruby forum supported us, including participation in ET. Thank you, Aaron, for reviewing English. Thank you. Finally, we referred some figures of mruby books and documents written by Kishima-san. We really appreciate it. That's all. Thank you for your attention.